Welcome to another solution walkthrough on Leetcode Simplified. I'm Alan, and today we're going to explore 4 different ways to solve Leetcode 242 valid anagram. Given 2 strings S and T consists of only lowercase English letters. Return true if T is an anagram of S, meaning each character has the same frequency in both strings. Let's look at the examples. String S has 3A, 1N, 1G, 1R, and 1M. String T had the same character counts, so these 2 strings are indeed anagrams. On the other hand, string rat has 1T, but string car has no T. Clearly, these are not anagrams. Now that we have a clear understanding what an anagram is, let's dive into the solutions, starting with the simplest one. The most straightforward approach is to sort the strings. First, a quick check. If S and T have different lengths, there's no way they have the same character counts. Therefore, they cannot be anagrams. Otherwise, if their lengths match, we simply compare the sorted versions of the 2 strings. If the 2 sorted strings are identical, they are anagrams. Simple enough. Let's go ahead and submit the first version. Boom. Done. This version runs in big O of n times log n because of sorting. The space complexity is big O of n to store the sorted strings of n elements. Sorted works fine, but can we do better? Absolutely. For a linear time solution, instead of using Python sorted function, we can leverage Python counter from the collections module. First, check lengths of S and T as before. Leverage Python counter to count the frequency of each character in both strings and compare. That's it, as simple as the first version. Time for submitting, and voila! The time complexity is linear big O of n, faster than sorting, especially for longer string, since we avoid the sorting step. And the time complexity is big O of k, where k is the number of distinct characters. How about an even better solution using constant space? You bet. Here's the idea. Use an array of fixed size 26 to store the counts of each character. First, initialize the array. Loop through each character in S and increment its count. Loop through each character in T. Find its index based on the ASCII distance from character A. Then subtract 1 occurrence from its count. Now check if T has more of this character than S. We exit. S and T are not anagrams. This crucial step skips a big loop if string T is large. At this point, we have looped through string T and all character counts match string S. Return true. They are anagrams. Let's submit this version. And boom! Accepted. Perfect. This version runs in linear big O of n time. Space complexity is constant big O of 1 for the fixed size array count. This is efficient both in time and space, but it only works for lowercase letters. What if the strings contain Unicode characters, anything at all like numbers, emojis, symbols, etc.? In that case, we switch to using a dictionary because it can handle any character type. Here's our approach. First, create an empty dictionary to store the counts. Now, loop through each character in S and increment its count. Then loop through each character in T. If it's not in the dictionary, return false at once. Else, decrement its count and check if its count drops to 0. Delete the character from the dictionary. Finally, after processing T, if the dictionary is empty, meaning each character has the same frequency in both strings, the 2 strings are anagram. Alright, let's submit our 4th and final version. And voila! Accepted! Great work! This version works for any character set and adapts dynamically, making it very versatile. So there you have it, 4 ways to solve Leetcode 242 valid anagram. Enjoy this video? If this walkthrough got your brain in spin, keep on coding, let the fun begin. Click over to my other videos and we keep smashing coding challenges together while sharpening our problem solving skill. Thanks for joining me. I can't wait to see you in the next one.